Stripping down science. The Naked Scientists.
Hello, welcome to this week's edition of The Naked Scientists. It's our question and answer programme with me, Chris Smith, and also with Dave Ansell. Hello, Dave.
Hi, Chris.
Now, coming up this week, scientists have uncovered the origin of the asteroid that wiped out the dinosaurs over 65 million years ago. And worse still, some of it's still up there in space. Find out where it is and whether it's going to make a return journey. Also, scientists have come up with a way to trigger nuclear fusion here on Earth. And also we'll be finding out why breastfeeding and smoking is bad news for babies.
Plus, we're trying to find out how astronauts can keep control of their stomachs in low-gravity conditions.
Given that gravity is required to separate the gases from liquids and solids in your stomach, the process of burping must be impossible or greatly diminished when in space. How is the excessive digestive gas expelled from the body? Because if there's one place you don't want to be farting, it's probably in a spacesuit.
So, not just a load of hot air. Plus, we'll be finding out how a new car made from cashew nuts, potatoes and marijuana can outperform a Ferrari.
Racing cars can have a conscience. You can have an environmentally friendly car that is good to drive and that is nice and fun. We've got a car here that has a better power-to-weight ratio than a Ferrari Enzo.
And in kitchen science, I'll be showing you a funky effect with friction. If you want to try it, grab two similar-sized paperback books, and I'll be telling you what to do with them shortly.
And also, as this is our question and answer show, in a second we'll be finding out whether plants can get cancer like humans can, and also why a fish that was bought on a market and then put in the fridge ended up glowing in the dark. And that was in Belgium. So don't eat fish in Belgium, perhaps. Find out later. If you've got any questions like that for us on science, technology or medicine, anything like that, we'll have a go at it for you. Email chris@thenakedscientists.com.
The Naked Scientists podcast, powered by UK Fast, the UK's best hosting provider. On the web at ukfast.net.
So what have you had your eye on this week then, Chris?
It's been a good week for science, I think, this week, Dave. For me, the sort of highlight was the discovery of where this massive thing that's thought to have slammed into the Earth about 65 million years ago came from. Because scientists at Boulder, Colorado, Bill Bottke and his team at Southwest Research Institute have published a paper in the journal Nature this week where they've managed to wind back the cosmological clock 160 million years to find where this massive body that slammed into the Earth came from. It turns out there was a huge great asteroid which has been so named as the Baptistina parent body, which is lurking out somewhere between Mars and Jupiter about 160 million years ago. Yeah. It was about 170 kilometres across, and from nowhere came another object about 70 kilometres across that smashed into it and broke it up. And it gave rise to at least 1,000 sub-fragments, some of them more than a kilometre across. And what they did was to end up in a part of the area of our solar system where the gravity between Mars and Jupiter approximately balances itself out. And this is what Bill Bottke calls a celestial trapdoor or escape hatch, because another effect can then kick in, and this is called the Yorp effect. And the reason it's called the Yorp effect is because it stands for Yarkovsky-O'Keefe-Radskiewski-Paddock effect. And what this is where the sun's rays hit something that's spinning, like a little bit of asteroid, and they give it a push because the light imparts a bit of energy onto the surface and makes it move. But if something presents a big surface to the sun and gets a big push, but then it turns around a bit and then presents a much smaller area to the sun, it gets more of a push in one direction than another, and this can start it moving. And what the researchers have done is to wind back the clock by retracing the orbits of all of these bits and working out how they would have formed this big body, and therefore how they eventually got pushed away by this effect and onto an Earth-crossing orbit, and they would have triggered a massive meteor shower lasting about 100 million years, a big object of which would have been about 65 million years ago, 10 kilometres across, that slammed into the Earth near Mexico, the Chicxulub crater at Yucatan Peninsula, which we think wiped out the dinosaurs.
So they're not absolutely sure it's not that asteroid that it came from, but they know that there are a lot of Earth-crossing asteroids which could come from there. I think
they've got it slightly firmer than that, because not only have they shown the maths adds up perfectly, they can be 90% sure, according to Bill Bottke. His own quote is, "We can say with more than 90% probability that this breakup event 160 million years ago looks like the origin of the impactor that produced the mass extinction." But they're also saying, if you look at the floor of the Pacific Ocean from drillings, if you take a core sample from the floor of the ocean, you can date it. And they found a meteorite in a core sample that dates exactly onto 65 million years ago. And if you analyse the composition of this bit of meteorite, it's exactly the same as, chemically speaking, as what we know is lurking out there where these objects would have come from. So they say they're pretty certain that this is what they found.
That's really neat.
I think it is. What have you got?
Well, this week there's been a new approach to nuclear fusion has been given the go-ahead near Oxford. Now, nuclear fusion is what powers the sun, and it involves smashing nuclei of light elements together like hydrogen. So they fuse together and releasing a huge amount of energy, which is different from conventional nuclear power, which involves splitting up large atoms to reduce energy and producing lots of radioactive byproducts. The problem with fusion is that you've got to get these nuclei close enough together, so you need to give them huge amounts of energy so they'll react. Now, one way of doing this, which has been funded a few months ago, is to confine them using magnetic fields, which ITER, which is a big project which got billions and billions of dollars recently, billions and billions of euros.
It's going ahead, isn't it? They're actually going to do that.
That's sort of, you confine them magnetically, you make them very hot, and then hopefully some of them react and you get energy out. Now, Professor Mike Dunn has got a slightly different approach. His idea is to get a very little there's a lump of frozen hydrogen.
Can you get frozen hydrogen?
If you get it cold enough, it'll freeze. You've got to get it sort of about maybe 4 degrees above absolute zero, 4 or 5 degrees above absolute zero. So really quite chilly, but you can freeze it. Yeah. And then hit it with a load of really, really, really powerful lasers. They've been doing that before in America. So you hit it with loads of powerful lasers, then the stuff on the outside evaporates, and that pushes the central stuff in, so it gets really, really hot and really, really compressed.
I get it. So as the stuff on the outside zips away trying to evaporate, it actually squashes the stuff in the middle harder. And you hope hard enough to cram the nuclei together so they want to start fusing. Yeah, this is a lot of the way a nuclear bomb, a hydrogen bomb works. So you fuse them together, and because the density is much higher than in the magnetically confined one, even though it's only hot enough for billionth of a second, you can still get a lot of energy. Sounds a bit dangerous, though, in Oxford, making a miniature hydrogen bomb.
But it's so small that the energy released is never going to be too much.
But why is that useful to mankind, then?
Well, actually, the idea is that then you can get energy out. If you can use this energy, then you can make electricity out of it, and it doesn't produce any not fossil fuels. It's not like burning fossil fuels. It doesn't produce any carbon neutral. It's carbon neutral, and it's much less radioactive than normal nuclear power.
But how would you refuel that? Because if you've got this tiny bit of hydrogen and it goes pop, doesn't that mean you've got to reset the whole system? Isn't that really
well, basically, he wants to use solid-state lasers, like the ones you get in laser pointers, to hit it. And he's using...
It's a big laser
The clever thing he wants to do, because other people have done similar things, is to hit it with 2 laser pulses, one fairly long, powerful one, and a very, very, very short, quite much less powerful one, which actually triggers the fusion. So you get it small, and then you hit it really hard, and it triggers it.
And what would you do? Have some system of being able to put a new bead in front of
this? You just sort of keep dropping beads in from the top, and you hit them with a laser as they drop past.
And how do you get the energy out again?
Most of it comes out in neutrons, unfortunately. So you'd have to have a big blanket of something like lithium, which would then absorb the energy and get hot, and that boils water.
And that does the next stage of
and it also has the advantage of producing more fuel from you later. Later.
Okay, well, let's hope it works. Well, when are they actually going to start building this, or is this all on paper at the moment?
They're talking about building it in the next sort of 10 years, and then maybe sort of 10 or 20 year timescale, be able to possibly build a commercial reactor.
Oh, well, let's hope it works. Here's an interesting thing, because how do fish eat? Doesn't sound like the obvious question for researchers to want to go and answer, but most people think, well, with their mouths. But the answer is, most of the time, they inflate their head a little bit and make a vacuum, and this sucks stuff up like a vacuum cleaner. And most fish do this, and most researchers thought that's how fish fed. But then there's a kind of fish called a moray eel, which is very long and thin, skinny, and it lives in crevices and cracks, and it couldn't literally expand its head enough to make a big enough vacuum to feed on enough stuff to feed a body that big, because it's a huge fish. How could it? It would have to have a really powerful suction to stop the squid and other cephalopods and things it wants to eat getting away.
Yeah.
So Rita Mehta, who is at the University of California at Davis, decided to start using very fast video photography to watch how these things eat, and uncovered something that wouldn't look out of place in the film Aliens, because what she found these moray eels do is they grab something with their teeth, because they've got a lot of teeth, and then if you watch, you see another set of teeth which are hiding down their throat come out of their gullet, grab the food in the mouth, then the mouth releases the food, and the second set of teeth that have been deployed pull it down into the esophagus. And they have said this is not just a sort of camera glitch. They've then done proper studies, the sort of eel equivalent of a barium swallow you'd do on a person. They've done the same thing and shown how this mechanism works. These pharyngeal jaws help to swallow things. And it's an adaptation that these creatures have got to help them eat big things that would otherwise get away from vacuum feeding, which is what fish do.
So no one noticed the second set of jaws on these?
No, it's so fast, eels. And no one had noticed they can actually deploy them from within their throat, because lots of fish have what are called pharyngeal jaws, extra little accessory sets of teeth in the bit they swallow with, but no one realised that these animals could move theirs and bring them right from behind their head into their mouth, grab stuff and pull it down. Ingenious. Imagine if
Wow.
we could do that. What we could swallow.
I'm not sure I want to think about it. Now, researchers in Toronto have developed a new form of display which they call a P-ink, which is actually inspired by butterflies. Now, most displays today work, whether they're conventional TVs, LCDs or LED billboards, they work by emitting light, which is great at night because it looks really bright and you can see it. But during the day, they tend to look dull and washed out. You may have noticed watching TV during the daylight is quite difficult because the daylight just kind of washes out the display that they're using. Now, André Ancelut, sorry, that's a French name which I can't quite pronounce.
If you put a French accent on there, no one will notice that you got it wrong.
Okay, André Ancelut.
Very good. I've just offended most of the French listeners.
Pardon. And colleagues.
You even apologise. Fantastic.
And colleagues at Opalux in Toronto have come up with a neat solution. Now, many iridescent butterflies and beetles produce really bright colours, not by using pigments which you're used to, like in paints, but by having lots of repeating structures at the right distance apart, which means just only certain colours will reflect really well. That's how really bright things like kingfisher wings and really bright butterflies
That iridescent, beautiful blue colour.
Yeah, that kind of really
that's actually
beautiful
structure.
colours.
It's not dyes. It's physical shapes that are reflecting light of certain wavelengths.
It's a similar way you get colours to how you see colours in a CD or how you see colours on oil on water.
And they've made a TV screen effectively do this.
Yeah, what they've got is they've got a load of little tiny silica beads. They've put it in a polymer. And so that it'll just sit there at a certain distance apart and that will reflect maybe green light.
Yeah.
And what they can do, by applying a voltage, they can change the distance between the polymer beads, which changes the colour.
So you get different colours.
So you get different colours. And actually you can change the distance so far that instead of reflecting red light, they should be reflecting infrared light. And because you can't see infrared light, then it looks black. So you can make any one of the colours in the rainbow.
So also this means that you presumably can get really high resolution because instead of having to have lots of different coloured pixels next to each other, you could have just one pixel, but it does all colours.
You couldn't quite make all colours because colours like brown are intrinsically a mix of different light, so you'd have to mix sort of red and
But
green.
you could presumably make these things so small that you could get really high resolution.
You make really high resolution. They also use very low voltages, very little energy to power them.
So when can I get a mega screen for my living room?
Well, they've only got them onto sort of building little sort of postage stamp things.
So they're really useful at the moment.
Not very useful at the moment, but they'd be really good for billboards because think really big billboards.
A postage-sized billboard.
Well, when they scale up, give them time. Okay. They should be able to print them. Scale it up to a whole billboard because they're reflective, so you wouldn't need loads of power to power the billboard.
Yeah, you don't need any energy apart from when you want to change them.
And they're probably better for that at the moment because they haven't got the time it takes. The time it takes to change is maybe a tenth of a second, so it wouldn't be good enough for video, but it'd be brilliant for billboards or books.
Thanks, Dave. Right, this is The Naked Scientist. In a second, we'll be finding out why, if you are breastfeeding, it's a bad idea to smoke because it can have previously unknown consequences for your baby, and we'll be talking to Julie Minella about that in just a second. It is also our science Q&A programme. Any science questions you'd like us to answer for you, you can email chris@thenakedscientist.com.
The Naked Scientists, supported by the Wellcome Trust.
Julie Minella is from the Monell Chemical Senses Institute. Hello, Julie.
Hello.
Tell us about this study which you've done on mothers who are breastfeeding but smoking as well.
Well, there really hasn't been a lot of research on the consequences of smoking while you're breastfeeding. And so there have been changes in policy here, and one of the questions that we had were, what are some of the short-term effects? And what we found is that if a mother smokes 1 to 2 cigarettes and breastfeeds the baby, even within the few hours after breastfeeding, we find drastic differences in the baby's sleeping patterns. The babies sleep less, they wake up from their nap sooner, and the greater the disruption in the sleep was correlated with how much nicotine the baby ingested.
When you say the baby slept less, how much less? Was it a significant amount?
Yes, what we did is we looked at the baby on 2 days. One day their mothers refrained from smoking, and one day the mother smoked, and not in the presence of the baby. And we found that the amount of times the baby slept was reduced by almost a half hour in just that 3.5 hour period.
So that's a reduction of, if you look at in 3 hours, half hour out of that, that's a good 40%, isn't it?
Sure.
So if the babies are sleeping 40% less, are they catching up some other time in the day?
That's a great question that we don't have the answer to. One of the interesting things is mothers who breastfeed and smoke, babies there's been a number of studies that show that they're more colicky and more active, and maybe this is one of the consequences of the nicotine exposure. We don't have the answers for cigarettes, but what we do know is we also get sleep disruptions alcohol is also transmitted to human milk. And what we can learn from those studies, if the mother doesn't continue to drink, the babies do compensate for it later on in the night. But the key is that the baby can't be exposed to nicotine again.
Now, I think there have been some studies that have shown that if you are exposed to nicotine as a young baby, there's an association with having learning difficulties or behavioural problems later on in life. Is that correct?
Yeah, and most of those studies were looking at the relationship between nicotine exposure during pregnancy and then learning disabilities during childhood. There's been very few studies that have really factored in the exposure during breastfeeding. One of the things is that mothers can reduce the amount of nicotine that the baby's exposed to by timing it. So unlike that which occurs during pregnancy, babies would sleep less. Getting back to your question, though, about learning disabilities, one of the functions of sleep is for memory consolidation and the forming of new memories. And so disruptions in sleep may be the mechanisms underlying that.
There's quite a significant difference in the amount of sleep they're getting, though. Do you actually think if you did this on large numbers of people, you'd see this effect maintained?
Pardon?
Well, you looked at quite a small number. You looked at 15 mothers, didn't you? So do you think that that's a small enough or a big enough number to draw conclusions from?
Well, what this study is what one calls a within subject. So you look at each baby on the day that their mothers don't smoke and compare it to when they did. So that's quite a powerful design. We know that there are colicky problems in infants. We know that nicotine is a known stimulant that has effects on sleep in adults. And so this is really consistent with a large body of research, but is now, when you think of the infant, you would even expect even a greater effect because they don't have the liver is not as mature and they're not able to break down the nicotine as well. So I would say that it's consistent with a large body of literature and also a literature in other animals that shows that nicotine is a stimulant and disrupts sleep.
If the mothers are kind of addicted to nicotine, would they be behaving differently if they haven't had cigarettes to when they had, and would that affect the babies at all?
Good question. Hasn't been a lot of research on that at all, so I don't have the answer to that one for you.
And do you think that because these babies are being exposed to nicotine, that, as you've shown it, in large amounts in breast milk, that this makes those children more likely to go on and smoke when they get older?
I like to think of it the opposite way too. Just like with alcohol, with nicotine, not every child of a mother who smokes or drinks is going to become a smoker or a drinker. What is it about what are the roles of early experience that put one child on one trajectory and the other? We don't have the answers to that. But I would add is that unlike that which occurs during pregnancy, a lactating mother can minimize the amount of exposure her baby gets to nicotine if she does smoke. And so that's part of the goal, too, in talking about the research is to get that type of information out there.
So what should if a lady wants to breastfeed, because we don't want to put people off from breastfeeding because we know that has the best outcome for babies, the best thing to do. So what should a woman do if she wants to be able to smoke and breastfeed her baby with the minimum risk?
I couldn't agree with you more, and I want to state that over and over. Breastfeeding is the ideal way to not only feed but to nurture infants. So if a mother's is smoking, what's interesting is women tend to cut down or actually stop smoking when they're pregnant, only to start creeping up back again later. The number one thing is try not to start smoking again. Having a husband who smokes contributes to the relapse, so I think father's got to take some responsibility here. And there really has been very little research on what's the most effective intervention to meet the needs of mothers for smoking cessation. The second thing is minimize the baby's exposure. Don't smoke in the baby's presence in confined areas like the car and in a home where the windows are closed. And also, what I want to tell them was what the time course is. When you smoke a cigarette, the nicotine levels in your milk are going to peak around a half hour to an hour and a half after you smoke. And then by 3 hours, they're going to really be at low levels. So you want to try to time your breastfeeds to minimize the baby's exposure. So wait a couple hours after you smoke. you can imagine just breastfeeding the baby and then having a cigarette if the baby breastfeeds every 3-4 hours.
Thanks, Julie.
Oh, my pleasure.
A wonderful story. Thank you for joining us.
Thank you.
That's Julie Minnella. She's from the Minnell Chemical Senses Centre. And this is Chris and Dave, and it's The Naked Scientists. And if you have any science questions for us, or you just want to say hi, email chris@thenakedscientist.com.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
Now, Dave, got a quick email here from Freddie, who is listening to us in Belgium, it would appear. And he says, last week I bought some fresh fish from the marketplace. It was cod. As my fridge didn't have a light bulb inside, that night I discovered the fish laying in the fridge and glowing a greenish-blue colour through its wrapping. Now, knowing that I live 20 kilometres from a nuclear power plant, I got a bit scared, and as soon as I could, I threw the fish away back into the river. How could this fish be contaminated? It looked very similar to the radioactive fish from the movie Guest House Paradiso, which I've not seen, actually. Maybe you have.
I haven't, no.
But was there something else going on? Was this fish really radioactive?
I'd be very surprised if it was actually radioactive, because to be radioactive enough to be glowing like that, unless it had a phosphor in there as well, in fact, even if it did, I think he'd be in serious trouble, because it'd be so radioactive he'd probably have serious radiation poisoning just by being near it.
The fish should also have about 5 eyes and 3 legs.
Or at least be very dead very quickly.
Yeah. Well, it was dead. It was in his fridge.
But if you bought it somewhere, I'm guessing they don't generally fish by picking the dead ones floating up off the surface.
Okay, so what do you think could be the explanation?
You definitely get some algae which will phosphoresce and give off light, especially if I don't know if you've been in the sea at night time in a boat, you can kind of see phosphorescent flows behind the boat. Where the water's been churned up, it sort of starts glowing. It looks really beautiful. I'm not sure if it's that exact type of algae, but I'd have thought some kind of biological algae, or I don't know, probably not fungus, but something biological is just glowing and making light.
Yes, one of these things that can take energy from one form and emit it as light. Yeah. Because I lost my wedding ring demonstrating that principle when I was on my honeymoon. So I went swimming in the sea at night time, and I said to my wife, look at this wonderful phosphorescence in the water. If I disturb the water, it will glow. And I watched my wedding ring go spiralling down in this wonderful trail of phosphorescence. So there you are. Mark in Bletchley says, how small will electronic components get? There must be a limit to the size that these things can become ultimately.
There definitely is a limit, because if you get too small, basically electrons, they're a bit like particles and they're a bit like waves, and if you get too narrow a gap between two wires, electrons can do something called tunnel between them. They'll sort of jump the gap, even if it's an insulator in between, they can sort of jump through the gap by a weird quantum mechanical effect. So if you get everything too small, then they start jumping across. And that limit is somewhere around sort of 10 atoms wide, 50 atoms wide, something around there.
How far away from that are we with microchips? Because there's a thing called Redwall, isn't there, which the semiconductor industry are making smaller and smaller microchips with more and more transistors packed onto them. And they're saying that there's going to get to a point where in about 2012-ish, then we're not going to be able to make things any smaller, and therefore we're not going to be able to make chips any more powerful because of the effects you've said. I
mean, not necessarily you can't make them more powerful, but you can't make them any more powerful the way we've been doing it so far, which is most of the gains we've got is by just making the chips smaller and smaller and smaller, because when you make them smaller, they'll actually run faster as well. But yeah, beyond that, I think they're going to have to start finding new technologies, or just packing more and more transistors up really big. Okay, I've got a question for you here, Chris. It's from Jeremiah Saringa in Ontario, in Canada. He's wondering, he's been watching bullfighting. He went to Spain, I think. And what makes a bull so mad about things which are red? Is there anything biological about it? What's going on?
It's the old saying, isn't it? A red rag to a bull. And we have this idea that bulls are in some way excited by red. But if you look at their eyes, they are dichromats. They have 2 colour pigments in their retina. They can see red, they can see other colours, but they would be, I suppose, on par with a colour-blind person. There's nothing special about red. I think what turns the bull on is that there's someone, usually wearing stupid-looking clothes, dancing around, prancing about with a big lump of wool or something. They're flapping in the bull's direction. The bull is generally hot, bothered and fed up, and that's why it goes for them. I don't think there's any evidence there's anything special about the colour red where bulls are concerned.
So are they sort of red-green colourblind balls?
Yeah, because I think they lack a pigment, which means that they only have 2 colour pigments in their eyes, where we have 3.
Yeah.
So where we're able to perceive this additional range of colours, they see the world in a similar sort of way, I think, to a colourblind person would.
So
Similar
if they're kind of red-green colourblind, then they'd start charging any bush rather than just red things, because they wouldn't really be able to tell the difference.
I think it's the movement that probably upsets them.
So it's not going to be the colour.
Yeah.
Okay, cool.
Now, let's do a bit of kitchen science, because I see you have got hold of 2 copies of my book, which is why I'm feeling a little bit nervous that my book is being involved in an experiment. You better not harm this.
No, they're very nice, new, very yellow books.
I know they're very nice and very new. Are they going to remain that way?
They should be. As long as we're not too violent with them, it should be fine.
Okay, what Dave wants you to do, if you're going to try this at home, is to go and find 2 paperbacks. And if you can find 2 copies of my book, I'll be very touched. But he's got 2 copies of this book, about the same size as each other. What have people got to do with it?
Okay, so we're going to show you how you can make books as strong as a person. Okay, so what I want you to do is take the 2 books. You may have done the kind of card sharpening shuffles, which you've seen on films, or possibly you can do them at home if you spend a lot of time playing cards at home. So
this is this fancy shuffle where you hold the cards and then leaf them so one goes and the other goes, and they pack up on top of each other alternately. So what
we're trying to do is interleave the pages on the 2 books. So we're going to get them so the 2 places where they open face each other, then move them close to each other, and then just gently sort of, you don't have to interleave one page to another page. You want to just interleave maybe 4 or 5 pages and 4 or 5 pages. So I'm putting in 4 pages from one book and 4 pages from the other book, and a few pages from one book and a few pages from the other book. This always takes far longer than you'd want to talk about on the radio. So if Chris can keep...
He's done about 10 pages so far. So what we're going to do is we've got one book sort of inserted inside the other one, haven't we?
Sort of, yeah, interleaving the pages. So you're going to get sort of about 50 or 60 changes from one book to the other as you interleave them.
Okay. And then what do you want people to do?
Okay, then I want them to push the 2 books together a bit so the overlap gets up to sort of inch and a half, so 2 or 3 centimetres.
So you've ended up almost with one book inserted inside the cover of another.
Yeah, that's the idea. Then hold on to 2 books near the spines and just try and pull them apart. See what happens.
Pull what? Hang on a minute. So explain, pull this books apart.
So you hold on to one spine with one hand, the other spine with the other hand, and just pull them apart and see whether you can.
Try and separate the 2 books.
Try and separate the 2 books just by pulling.
Well, that doesn't sound too difficult. Why is that special?
Try it. Let's find out. That's the whole point. Experiment.
Okay. All right, well, we'll come back to Dave with my book later in the programme and see if he manages to destroy it or not. Dave, got some quite interesting questions here. We've got... Mike in Essex says he had a urine test and it came back with a high protein. How does the protein get there? Well, the answer, Mike, is you have lots of protein in your blood, because what your blood does is it needs to go through small blood vessels called capillaries, and these are very leaky. And if you had blood just shooting at high pressure through blood vessels and they were leaky, the blood would all come out through the holes and it would be difficult to get the blood to go back inside the blood vessel to go back to your heart. So you have these proteins that can't get out of the blood vessels, and they attract water to themselves. They act like a giant water sponge, and they pull the water back out of the tissue and keep it in the blood vessels. You have similar blood vessels like that in your kidneys. They're not supposed to let protein go out into your urine, but sometimes when they become a bit too leaky, then they can. And there are some diseases which are associated with having high protein in the urine, and if that's been picked up, it needs checking to make sure that there's nothing going on, needs verifying. Might not be a real finding the first time, so check it again. But there are various things that can cause it, and if it is there and it is a real finding, then you need to look into it and make sure you can get it sorted out.
Cool. I've got a question here for you, Chris, from Anil Sodhi. Apparently he lives in the US, but he grew up in Malaysia. His question is whether plants and trees can get cancers, and if they can't, why not?
They can, but not in the same way that a human would get a cancer.
Okay.
What we describe as cancer is an abnormal proliferation or growth of cells in a certain part of the body. Those cells grow invasively. They can damage surrounding tissues by growing into them, growing into blood vessels, causing things to become abnormal at that site. But then the other defining thing about cancer is that it can spread, and it can go into the blood system or into the lymphatic system. Cells can break off from the cancer, trickle through the bloodstream and go to other parts of the body and set up miniature tumours there. That's called metastasis. Now, plants can't do that, but they can have these abnormal proliferations in certain parts of the plant. And just like some human cancers, viruses and bacteria can cause them. Now, in humans, we know there are various bacteria that can trigger cancers. Things like Helicobacter pylori, which lives in the stomach of quite a lot of people, can cause stomach cancers, and it can also cause ulcers. And there are various viruses, such as a human papillomavirus that causes warts and verrucas, but can also go onto the cervix and cause cervical cancer. In plants, there are various things that will do a similar thing, plants have a bacterium called Acrobacteria tumefaciens, and this inserts little bits of DNA into the plant's DNA and makes the cells grow uncontrollably, and you get this thing called galls, or crown gall disease, and it can happen on the stems. There's a different species of the bacteria, and it makes it happen on the roots, and there are various other things that can happen to plants in a similar vein. But these things don't break off and go to other bits of the plant. They stay localised, but they can become very big. So I suppose in one respect, plants can get cancer.
Cool.
Got a quick one here. Roy in Chelmsford. No, let's first of all, Roz is in Girton and says, can you tell us why, when we cook plums, they taste so sour?
I can't. Have you got any ideas, Chris?
You'd think that the sugar would be a bit more concentrated. So is there well, the only thing I think of is there something else in the plum which is coming out when you break it open, and by cooking, I mean, and it's got a sour taste. Is there something else coming out or being extracted or broken down by the cooking process?
I'm not sure. Are the skins of plums quite sour normally?
Well, they are a bit, aren't they?
Yeah, and whether that's getting released or there's just another chemical reaction going on.
I guess, Roz, you got us a bit stumped on that one, so we'll have to... Maybe someone can help us. I don't know. I've got a couple of emails here which we should look at, which... This one made me laugh. I'll show you why. It says, "Hi, Dr. Chris. Do white chickens with white earlobes lay white eggs? And do brown chickens with brown earlobes always lay brown eggs? Or do the colours of chickens' eggs have another deciding factor?" This is not a joke, it's just a query, maybe a question of the week sort of thing. But the reason I'm a little bit concerned, it might be a bit of a joke, is because the person who sent it in is called Shelley. But if anyone out there knows, I've no idea what determines the colour of chickens' eggs. If anyone knows the science behind it, I know diet can play a bit of a role, but if anyone knows, and certain species of chicken definitely have different coloured eggs, don't they? But if anyone
when I grew
knows...
up, we had chickens, and some definitely, they all looked similar, and some had brown eggs and some had white eggs.
So if anyone kind of knows what's going on with chickens' eggs, that'd be good. And this one, Dave, I don't know if you can help with this, but it's from someone called Dave, and I've seen this, I believe this. Dave Packham says, "I have a new low-energy light bulb in my bedroom. When I switch the light off at night, it flashes about every 40 seconds. It's not bright enough to see in the daytime, so you only notice it at night." And I've had the same thing. Is my wiring dodgy in my house? I had a low-energy light bulb. I thought I'd be very environmentally friendly. I put this in my bedroom. I've had the same thing. Why is that?
I'm not sure what it is. I've seen similar things with fluorescent tubes, whereby in my girlfriend's house, she used to have a fluorescent tube above the bed.
Along with the glitter ball and the mirror.
Anyway, yes. And if it was plugged in and you turned it off, sometimes it would just glow. I don't know if it's a similar effect, because I don't know if you've ever played with one of those plasma balls, the things whereby you get big sort of sparks coming out when you touch them with your fingers.
Yeah.
Those work with very high-frequency electricity. And you get sparks, they're very high voltages, and you get sparks through the gas inside them. And when you touch them, and if you touch them and then you hold on to a fluorescent tube, it'll start glowing.
Yeah, but the power's off, though. So why should this happen?
I was wondering whether you could get something called capacitance, which is whereby it's capacitive coupling, whereby if you've got two big plates and you have an oscillating electric current on one plate and you have another plate near it, the voltage on that plate will change as well.
But where would that be coming from if the light bulb is off? Is there some power leaking into the negative line which is not on the switch, do you think?
You could... normally you only switch off one side of the power.
That's what I'm saying. You normally turn the positive rail off. So
you'd still get some voltage change on the other side.
Yeah, so if there's power leaking onto the neutral line, is that enough?
It could be enough to transfer a very small amount of power into the circuit and just stimulate the light bulb.
So if there are any electricians out there who can help us with Dave's question, 08459 25 2000, email chris@thenakedscientist.com. Dave, Douglas in Southend says, "Why do the numbers on my phone go 1 to 9 top to bottom, but on my PC they're the other way up?"
I don't know. I guess it's just... I don't know.
Some funny convention?
It's a convention, probably, that's just... I mean, because phones have always been that way for a long time. I guess it's kind of taking a dial, and your dial one would start off at the top left, and work downwards. I guess, actually, with a computer keyboard, possibly you type 0 more than all the other ones, so you want you to have your thumb above the 0 key, so that's quicker. But otherwise, I don't know. If anyone knows the history, that would be great to know as well.
Thanks, Dave. It is The Naked Scientist with Dr. Chris and Dr. Dave. It's our science Q&A show. If you have any questions you'd like us to solve for you, email them in, chris@thenakedscientist.com. Now, we're all being asked to lower our carbon footprint, and one area where you think this would be nearly impossible is the world of Formula One racing. But scientists are now working on a way to reduce the damage that results from this sport. So we sent our own Meera Sinthalingam along to the Science Museum to find out how.
Everything you hear about these days has a green or eco-friendly statement attached to it, and cars are bang in the middle of it all. I'm sure you've probably heard of biofuels, but how exactly do these benefit the environment? Biofuels, like bioethanol and biodiesel, are a whole new type of fuel that run cleaner and save those precious fossil fuels. When we burn fossil fuels, we release carbon dioxide and increase its concentration in the atmosphere. But biofuels are made from plant sources, and as plants absorb CO2 from the atmosphere to photosynthesize, the CO2 released from burning plants in the form of biofuels doesn't produce a net gain in atmospheric carbon dioxide in the same way that fossil fuels do. But the image of eco-friendly doesn't really put them in the same league as a Ferrari or a Porsche, does it? Well, not anymore, because a group of scientists at the University of Warwick have set out to do just that. They plan to get eco-friendly cars not only into this league, but make them better than those flash midlife crisis bank-breaking beasts and get them into the world of Formula One. The team recently displayed their results at the Science Museum in London, so I went along and had a chat with Ben Woods, research engineer on the Warwick team.
The bodywork's made from hemp, or marijuana as some people know the plant as, and it's held together with a resin made from plant oils. The tyres are made from about 1.5% potato starch, which replaces some of the fossil fuels and nasty bits and pieces that go into a normal tyre compound. We've got cashew nut brake pads, believe it or not. They're made from cashew nut shells and various other bits and pieces. Then we have bioethanol fuel made from wheat and oil made from plant oils, again, it's completely biodegradable.
So is this total car biodegradable?
We think between 90 and 95% either biodegradable or recyclable. Some of the metal components are recyclable, but we can't replace those for safety reasons with environmentally friendly materials. We basically wanted to show that racing cars can have a conscience. You can have an environmentally friendly car that is good to drive and that is nice and fun, because quite often the misconception is that they have to be slow and boring. So we've got a car here that has a better power-to-weight ratio than a Ferrari Enzo.
Are you going to be racing this? What are you going to be racing it in?
We're a bit of a victim of our own success in that this is the only car of its type in the world, so it's very difficult for us to race anything. But we've got Eco 1 Squared in the pipeline, which is the slightly twee name for the second generation of this car. That's going to be a Formula 2000 chassis, and basically we'll be hoping to race that using a biodiesel-powered engine.
So could I just ask, how fast does this vehicle actually go?
Sure, well, Eco 1 will hit 60 miles an hour from a standing start in about 3 seconds, has a top speed of between 140 and 150 miles an hour.
That's impressive. Are you looking to expand that for your squared version?
Well, that car will actually have downforce. It'll have big wings like a Formula 1 car, so we're hoping it will be a bit more stable around the fast corners. I've only taken this car up to about 120 at the moment through fear.
What do you think, the future just for, say, more everyday cars is?
Well, we'd like to think that a lot of the technologies and the materials that we've used can be carried over to the mainstream automotive industry, such as the tyres, the oils, the fuel and the brake pads. The body panels can be carried over into other forms of motorsport, and it's excellent doing an event like this because it means that we can enlighten people about the materials and technologies that are available to them.
So you're out to just prove that eco-friendly cars just don't have to be slow and boring?
Absolutely right, yeah.
So there you have it. The must-have vehicle of the moment isn't a gas-guzzling Chelsea tractor, but an emission-reducing eco-friendly car. Soon, you could see Lewis Hamilton racing around the track in potatoes and hemp. Just wait and see.
So, naught to the mortuary in about 10 seconds. That was Mira, who was talking to Ben Woods about making Formula One go greener.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
This is The Naked Scientist, Dr. Chris and Dr. Dave.
Now, I've got another question here for you, Chris, from a guy called Tony, and he asks, why do runner beans always grow, the tendrils come out, always grow in an anti-clockwise direction?
It's a bit like wisteria, isn't it? Because they wind in a certain consistent direction, and there are a few species of wisteria. And when I was in Singapore, I don't know why when I was in Singapore, but I was in Singapore on my way to Australia, and I went to the Botanic Garden, and if you have the chance to ever go to the Singapore Botanic Garden, it's stupendous, absolutely amazing. And I learned all I know about wisterias from there, because I know that there's one species that does wind the wrong way, but the bulk of them do wind in just one direction.
Yeah.
And the reason for this is that when they assemble their cells so that they grow, the cells of themselves are slightly asymmetrical shape. It's a bit like the steps in a spiral staircase. So when you plug them together, they automatically impart a twist to the structure of the growing stem. It wants to turn because it's using building blocks that are an asymmetrical shape. And if you affect that symmetry, then it'll wind the other way. If you reverse the symmetry, it'll wind clockwise instead of anti-clockwise. So it's all to do with the shape of the cells that do the growing and how they're assembled relative to each other.
And I guess if you had a load of cells, which you could have two different types of cells, which would either twist one way or the other way, they'd average out to be straight-ish, and it wouldn't actually curl. So if you're a plant... It depends
if it wants to be a climbing plant.
Yeah.
Clematis, things like runner beans, wisterias, other plants that want to climb, bindweed, they do this and use this asymmetry because it naturally allows them to twist around things. Clematis also has the ability for its leaves to wind in circles and things, but these winding plants do this, yeah.
So, yeah, if you're a climbing plant, it'd be a really bad idea to have two possible things. So it's much better to standardise on one, and then it'll always twist.
Yeah, otherwise
correctly.
It would unwind itself and fall down. Alan's in Orpington. Hello, Alan.
Yes, hello there. Good afternoon.
Welcome.
Dr. Chris. Last week there was the World Championships for the moustache and beard competition in Brighton.
Have you got a beard?
Have I got a beard?
Yeah.
Yes, I have.
So how long's your beard?
It's tiny, I shave it daily. With
okay. So you actually, you're sort of keeping your beard in check.
I'm a stubble man.
Right. George Michael, designer stubble.
Yeah. Just in case you want to strike a match. Basically, I was wondering, some of the contestants had the most amazing beards and moustaches. And it set me wondering just how long or how fast would a beard or moustache grow? What speed does hair grow at?
On average, across the body, a couple of millimetres a week. So 2.5 millimetres. Head hair, that's what we've got the best data for, grows at about 1 centimetre a month, on average.
Mm-hmm.
And it depends on... There are several things that determine how long a hair grows for. Hair has 3 phases in its hair follicle, and there's an anagen phase, that means growth, and the hair, when it's in its anagen phase, is getting longer. Then it goes into a catagen phase, that means breakdown. The hair follicle switches off, the hair falls out, and the hair follicle then stops for a while. Then it goes into this telogen phase, which is when it rests for a while, and then it goes back to the beginning and starts growing hair again. So the length of that anagen phase determines how long the hair becomes ultimately before it drops out. And that's why we have eyelashes that tend to get a certain length before they drop out. And you don't end up with eyelashes you need to cut or that droop down in front of your face and sort of block your vision. But on your hair, the anagen phase, the growth phase, is much longer, so you get very long head hair.
So, your eyebrows as you get older
can get a bit bushier, yeah, that's right. There's 2 things to that. One is that you get hairier as you get older on certain bits of your body. So in us guys, the testosterone we have in our bloodstream makes you get hairy. You get hairier ears, hairier nose, hairier face, and things like your eyebrows do become bushier. So there's a certain element of that is bushiness. And also, the hairs, I think, probably do grow for a little bit longer, but I'd have to check that.
The last question about the wisteria sort of twisting and curling in one direction or another. I suppose you could carry that forward, and maybe that's the same with hair. Does that work the same way? Because we get curly or not so curly.
Yes, you're absolutely right. And in fact, I'll apply it to feathers rather than hair, because that's what we have the best evidence for. Scientists discovered the stem cells that birds use to make feathers. And the reason I'm drawing analogies between beards, hairs and feathers is because feathers are birds' equivalent of hair.
Yeah.
And the same follicles that give rise to hairs in us give rise to feathers in birds. And what researchers found in America last year, and published a very famous paper, was that in feathers that are just downy, that keep them warm, the circle of stem cells sitting in the hair follicle is a perfect circle. Mm-hmm. But if you look at flight feathers, they are angled, they're twisted a bit, so that they can create the air currents that give the bird the right sort of lift.
Yeah.
You know, the feathers are not symmetrical, are they, if you look at the birds for flight feathers? And if you look in the follicles that make those, the ring of stem cells is twisted. It's like a circle tilted on its side. And this gives asymmetry to the structure. And probably the same thing is true for why our hairs have, on certain parts of the body, different growing characteristics, I think. That would be my speculation.
So on that basis, the difference between a pillow full of duck hair or chicken hair, a chicken would be less fluffy because it's straight, and a duck would be curved and be more fluffy.
When you say straight, you're not talking about its sexuality, presumably. I'm not
going there.
Well, Dave normally has an opinion on all things farm-related, and I mean that in the nicest possible way. He came from a farming family, so I was looking to Dave for some moral support here.
I'm sorry.
None was forthcoming. Anyway,
Thank
Alan,
you,
that's all right. Thank you for joining us on The Naked Scientist.
Okay, fine.
Thank you, Alan. Alan in Orpington. If you'd like to ask us any questions, you can email chris@thenakedscientist.com.
It's Chris and Dave on The Naked Scientists. Now, it may be true that in space no one can hear you scream, but can they hear you burp? Here's Diana with this week's question of the week.
Hello and welcome to Question of the Week with me, Diana O'Carroll. Today we'll be jet-propelled through the cosmos with Aaron's question on astronaut diets.
Hello, my name's Aaron Jenkins and this is my question. Given that gravity is required to separate the gases from liquids and solids in your stomach, the process or effectiveness of burping must be impossible or greatly diminished when in space. Assuming that the total amount of gas produced during digestion of food is independent of the strength of the gravitational field, how is the excessive digestive gas expelled from the body? Because if there's one place you don't want to be farting, it's probably in a spacesuit. Does this problem exist? And does NASA take this into account when designing menus for astronauts? Thank you very much.
So is space wind a real issue for the average space person? And if so, do they need to eat more probiotic yogurt? A quick call to NASA solved the problem.
My name is Vicki Claris. I work at the Johnson Space Center in Houston, Texas. I manage the NASA portion of the International Space Station food system. The question was submitted regarding burping in microgravity, and the person who submitted the question was correct in that the valve at the top of the stomach does depend on gravity to help. So therefore, what happens in microgravity is that crew members very often experience wet burps instead of the dry burps that we would experience on the ground, and this can be very unpleasant. Therefore, crew members often will spread their eating out rather than eating a lot of food at one time. Some may choose to spread it out and consume smaller quantities of food at once so that their stomachs are not as full, as that will help with this issue. But it also shows that should we be able to make a carbonated beverage, say like soda, available on orbit, that very likely crew members would not be comfortable consuming a lot of carbonation in their diet due to these issues with burping in microgravity.
It looks like we can burp in space as much as necessary, but it won't be nearly as enjoyable as it is on the ground. Once upon a time, every effort was made to avoid gaseous emissions through changes to the diet, and Dr. Schiller from the University of Wisconsin-Madison informed us that a famous fizzy drinks brand even cut out their bubbles for space drinks. From blowing bubbles in space to blowing them underwater, next week we'll be considering Dirk's question.
Hi, my name is Dirk England. Some animals, such as amphibians or seabirds, need to see above and below water. My question is, how do they do it? How do their eyes work in air and in water? Thanks, and I greatly enjoy your show.
And beauty is in the eye of the beholder. So why do cuckoos find other cuckoos attractive if they're raised by a different species?
Hi, my name is Dick Hawkins. I'm calling from Napier in New Zealand. I've got a small aviary at home with several different species of birds in it, and every so often when I have to add another one there because of natural losses, the different birds always seem to know what they are. They don't get confused. The budgies don't try and mate with the canaries, and the finches don't shack up with the canaries. So I was wondering how they actually knew what they were, and I assumed it was just from how they were brought up by the parents. It then did occur to me that how on earth do cuckoos manage? Because cuckoos being brought up by a foster parent of a totally different species eventually go off and spend a life as a cuckoo, behaving like a cuckoo and finding another cuckoo to mate with.
How is it some animals can see clearly above and below water when humans can't? And how does a cuckoo know it's not supposed to mate with a wood pigeon? Send your answers and new questions to me with the address questionoftheweek@thenakedscientist.com. Back to you guys in the studio.
Thanks, Diana. So if you know what makes a cuckoo, or how diving birds can focus both in and out of water, let us know by emailing questionoftheweek@thenakedscientist.com.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.
And this is The Naked Scientists with Dr. Chris and Dr. Dave. And next week we're going to be up in York, actually, because it's the BA Festival of Science, which happens every year. They go to a different part of the country every single year, and the idea is to make science fun and interesting for the masses. We're going to be there, and one of the people who's responsible for setting up is Sue Hordchenko. Hello, Sue.
Hello.
Welcome to The Naked Scientists.
Thank you very much.
Now, what are you going to have on offer for everybody in York?
Well, there's about 350 different events, exhibitions, talks, discussions and debates going on across University of York campus and also in various different venues across the city, starting today and going on until next weekend.
And what sort of level of education do people need to have to come to this thing? They don't need a PhD, presumably?
No, not at all. It's extremely varied programme of activity, so it spans across all of the sciences. We like to find scientists who have extremely good communication skills, so it's very much aimed at a lay audience.
And what are the highlights? What sorts of things would you say is going to definitely be on your wish list to drop in and see?
Well, when I finish talking to you, Chris, I'm off to listen to Robert Winston talking at the York Theatre Royal. So he's going to be in conversation with broadcaster Sue Nelson. He's going to be giving us an insight into what it's been like working within the area of fertility all of those years and really, you know, what it's like to be a scientist working very much in the media spotlight. So I'm off to see him later on. I think that should be very good. Being a bit of a chocolate fan myself, we've got an event on Tuesday taking place on the university campus which looks at some of the scientific issues raised in our passion for chocolate, including the notion of whether or not chocolate addiction does exist.
I think it certainly does, if you ask my wife.
And if you ask me as well. It's also going to be looking at some of the conflicts that have arisen over the years where cocoa has been concerned. We've got some events on natural disasters, earthquakes that are taking place on Wednesday. Should be quite interesting. Also on Wednesday we've got an event which looks at the truth about hypnosis, and an event with which looks at rock guitars in 11 dimensions. So I'm sure you'll say from that, Chris, that there really is quite a diversity of activity taking place.
And if people want to come, are they going to have to dosh up loads of money, or is this going to be something that they can get good value for money from?
The tickets that are priced are extremely reasonable, and there's also quite a lot of free activities taking place that people can drop into as well.
OK, well, thanks for joining us, Sue, to talk about it. So the bottom line is if people want to come up to York this week, there's going to be plenty going on, and they make their way to the university. Is that right?
That's right. Or there's a box office number that I can give you as well if people wanted to write down.
Go ahead.
01904 433 281.
OK, thank you very much, Sue Wojcichenko from the BA. Have a great festival.
Thank you very much.
And we'll be up there all of this week. And in fact, our programme next week will be reporting some of the best of the fest. If you cast your mind back a year, we were there in Norwich because last year it was the BA Festival at the University of East Anglia in Norwich, and we covered it for this region. And so we're going to head up there and see what's going on tonight, actually. Dave, this kitchen science experiment, I'm getting nervous again because you've got 2 copies of my book sitting there. You asked people to leave the pages together, sort of so one book became inserted into the other, and then you said pull it apart, which got me a bit nervous. But what are we doing here? Well,
so we've got the 2 books. I've interleaved them. I'm just going to push them together so they get a really good overlap. So a good sort of inch and a half, 2 inches of overlap, which is a slightly interesting exercise.
OK, so the 2 books now, the pages of one book are inserted between the pages of the other book. OK, so what do you want people to do?
Right. Now, Chris, you're a big, strong guy, aren't you?
Yeah.
Now,
so I say, yeah.
Now, what I want you to do is grab those 2 books by the sort of spines and just try and pull, see if you can do anything.
OK, it doesn't look hard at all. Oh, my God. OK, I'm not making this up. I'm pulling as hard as I can, and am I going to ever get these apart? I cannot separate these 2 books. I cannot separate these 2 books. So why are these 2 wonderful books of naked science by Christopher Smith stuck together in this way? Is it because of the quality of the writing and the paper?
Unfortunately, it has nothing to do with the quality, which I'm sure is very high, Chris. What it is, if you push your hand against a table, and if you don't push down at all, it will just slide very easily. There's no friction there. But if you push down a bit, there's a bit of friction. The harder you push down, the more friction there is, so things tend to stick together. Now, with these 2 books, when you pull them apart, you get a little tiny force because when you pull them apart, it tends to just sort of flatten them. It's just a little tiny force compressing everything together. And normally that would be so small, it wouldn't have any effect and to pull apart it really easily. Because you've interleaved it loads and loads and loads and loads of times, that force is multiplied by the number of interleavings. So
the number of pages in the book. If you've got every page.
Yeah.
So 200 times the friction.
Yeah, so if maybe that was only sort of 1/10 of a kilogram, if it was 200 times that, it would be holding 20 kilograms. times the maximum force. So just because there's this interleaving, you multiply the force up to, so it can be really huge, and you're just not going to be able to pull it apart.
So if someone's got their books at home stuck like that, how do they get it out apart again?
Well, it's very easy. All you have to do is basically just uninterleave it. So just pull the interleaves upwards, so a couple at a time, and it just comes apart really easily. It's like that.
That's wonderful, but how does this actually have any relevance to everyday life and science?
Well, if you want to attach two things together, maybe glue them together, it's really useful to be able to use this sort of principle. So I don't know if you ever looked at the corner of a drawer where they've got the wooden joint at the corner. That tends to be lots and lots of different things overlapping in the same, interleaving in the same sort of way.
Like little fingers of wood in a mortise tenon
joint. Yeah, that's the idea. So instead of having needing a huge force to hold it together, which would just pull the wood and the glue apart, you spread it over lots of separate small joints. So you need much smaller joints, so it's much easier to do, and the glue doesn't have to be so strong.
Brilliant. Thank you, Dave. More wonderful kitchen science experiments like that on our website. Probably about 100 of them by now. It's at nakedscientist.com/kitchen science. Bernie's on the line. Hello, Bernie.
Hello.
Welcome to the Naked Scientists.
Oh, thank you. I've heard stories about outfalls of power stations at the sea getting sort of colonies of fish that wouldn't normally be in the area.
Yeah.
I suppose this is likely because the warmer water, but maybe it's just a story, but are there certain breeds of fish that would prefer to go to a nuclear power station than a normal one?
The water coming out of a nuclear power station should be identical to that coming out of a normal power station, because the radiators, there's really close.
It's nice warm water,
things.
Isn't it?
Yeah,
Because at Bradwell-on-Sea, where the power station used to be, a nuclear power station there, it's now shut down. I used to sail there. And the water was gorgeous. In fact, we used to take, when we were teaching children to sail, we used to get them sailing inside this baffle wall where the water coming out of the power station would come out, because it was so warm. If you fell in, it didn't matter. It was like a bath. But Dave, I guess what Bernie's saying is, are there other species of fish that might be there, or in greater profusion because of the conditions created by that warm water?
Definitely because of the conditions. I mean, I think up near Hinkley Point they've found fish which you normally find in the Mediterranean there, because the water never gets very cold, so they can survive the winter.
And also, I suppose you're going to have other kinds of things and organisms growing which might provide more food for the fish, so you're going to attract more fish in general.
Different fish and different other aquatic species.
So I guess that's a yes then, Bernie.
Yes. Could have done with a nuclear power station where I used to teach sailing in Peterborough as well, then.
Yeah,
especially in the winter.
Can't have everything. But look, thanks for your call, Bernie. Great having you on The Naked Scientist. Thank you.
Laying the facts bare, The Naked Scientists.
Well, that's it for this week. Thank you very much for listening. It's a huge privilege for us to have you supporting this programme, and we really do appreciate it. Also, thank you to our wonderful production team here at The Naked Scientists. That's Ben Valsler, Mira Senthillingham, Diana O'Carroll and Petro Minch. We couldn't do it without you. Next time, we'll be bringing you all of the best science stories from the BA Festival of Science, which this year is happening in York. But do please keep sending in your science questions, or even if you just want to say hi, we love hearing from you. The email address is chris@nakedscientists.com. Once again, thank you very much for listening, and until next week, goodbye.